Algebra 1, Day 69. So today we're going to be talking about solving quadratics by factoring again. Except this is the slightly cray-cray edition, meaning that it's going to have a little bit of an extra step. And sometimes you'll see this on standardized tests and other things like that, where you have to rearrange everything to make sure it's equal to 0. So let's go ahead and take a look at it. All right, so everybody go ahead and get your notes page ready. So, in order to solve quadratic equations using, my factoring, these equations must be written in standard quadratic form, meaning ax squared plus bx plus c equals 0. It's always got to be equal to 0. And of course, then we can solve or factor in order to find my 0, which we also know as my x-intercept, my root, or a solution. All right, so summary version of this. Essentially, we're doing the same exact thing over and over. All we're doing now is sometimes we might have a number over here that's preventing us from having it equal to 0, and we just got to move it over. Or we just have to move a couple of terms around to get them rearranged properly, okay? So let's take a look at this very first one. So first thing I want to do is I notice this is not equal to 0. So I'm going to go ahead and get that 12 moved over. And I'm good. Now I can go ahead and take a look at this and start with my factoring process. So first thing I'm going to do is I'm going to multiply a times c, 1 times 15. So I need two numbers that will multiply together will give me 15, but when added together will give me positive 8. I'm going to make the assumption these are probably positive numbers because there's no negatives here. So I'll say, I don't know, 1, 15, 3, 5. There we go. 3 and 5. Okay. So now I'm going to go ahead. I'm going to take my b value. I'm going to split it apart. Now I'm going to go ahead and I'm going to factor out from just the first two. Then I'm going to factor out from just the second two. I'm going to verify that the insides are exactly the same. And if they are, I can combine like terms. And, of course, I can split them apart and go ahead and solve it. All right. So I got it. But let me just verify this answer in my calculator. So if I graph this, and I have to graph the form after I move my 12 over, I should see a 0 of negative 5 and a 0 of negative 3. Let's go ahead and open up a new graph. And I'll go ahead and do a graph trace. So I'm going to head on down to that 0, negative 3, just like we predicted, negative 5, just like we predicted. We got this one right. So let's go ahead and move on to the next one. So for this one, they were really playing games. They moved that b and associated x to the other side. But all I have to do is just do the opposite, inverse operation, and I'm back in business. Now I'm equal to 0, and I can start the process of factoring. A times c, 1 times negative 15. I need two numbers that when multiplied together will give me negative 15. However, when I add them together, they got to be 2. That means that I probably have one negative number, and the positive number is bigger because this is positive when they're added together. So I'll say negative 1, positive 15, negative 3, positive 5, and there are my numbers. So now I can go ahead and I can split this apart. And I can go ahead and factor out from just the first set, factor out from just the second set. I'm going to ensure that the inside is exactly the same, and it is, so I can go ahead and combine like terms. Now I can split them apart. And I can go ahead and get my x solved for. So if I graph this, x squared minus 15 equals negative 2x, I should see a root at negative 5, positive 3. Let's try that out. Let's start a new graph. So I got that graph for us. I'm going to go ahead and do my graph trace. And I'm going to verify that I see an x-intercept at negative 5. Let's see, negative 5. And there should be one at positive 3 if I did this right. Positive 3. So I got it right. We're all good. We got the correct answer. All right, let's go ahead and take a look at one more example. So we could do this by moving the x squared. We could move the 2x and the 5. It's really a personal preference. I will go ahead and I will just move my 3x just because it's one less step. All right, so now that I have this, I can go ahead and start factoring. So first thing I want to do is I want to go ahead and multiply a times c, 3 times negative 5, negative 15, and I need two numbers that will multiply together, give me negative 15. However, they need to add together to give me negative 2, implying there's at least one negative number, and the negative number has got to be larger. So I look at this and I say, all right, well, that sounds very similar to the situation before, so let's try 3 and 5. And look at that. That is the correct numbers. So I'm going to go ahead and I'm going to break this apart. Now I'm going to go ahead and I'm going to factor from just the first set of terms. And then I'm going to factor from just the second set of terms. I see that the insides do most definitely match. So I'm going to go ahead and I'm going to combine like terms. And I already know my rule. Opposite of the number that's by itself divided by the coefficient of x. 5/3 and negative 1. So I should be able to plug in my original equation and verify that I have roots at these locations. Let's go ahead and do that. So I'm going to go ahead, I'm going to start a new graphing page. I'm going to type it in 3x to the power of 2 minus 2x minus 5. Okay, I'm going to go ahead and do my graph trace. Okay, so I'm going to go up negative 1 as we predicted. And 1.67, which is approximately 5/3. So we got this 100% correct. All right. So I want you guys to go ahead and get started on this part, remembering personal preference. If it was me, I would just move over that 8x. We don't really care about whether or not it's positive or negative right now. All we care about is solving it. Okay? All righty. See you guys next time.